All right, so this is chapter 18, which is our first data modeling example. We're going to model a session store here. This is going to be the easiest example we do, but we're still going to walk through that same process we do in every one. So let's just remind ourselves what that process is. Number one, understand your application. Know what you're trying to do. Know how it all fits together before you even get started. Number two, you want to build your ERD. You want to know what the entities are in your application, those objects, and how they relate to each other, those relationships as well. Third, once you know that, then define your access patterns. So work with your PM, your business analyst, whoever it is, your engineering lead, and figure out what are the access patterns you have in your application. Once you have all that, then you get into the actual table design where you design your primary keys, your secondary indexes to handle the patterns that you have. So let's get started with that first part where we understand our application. And what we're doing here is we're building a session store. This is going to be used for authentication. So imagine we have some sort of backend service for our application. Maybe we're building a social application where people can post messages, tweets or DMs or anything like that. And as part of that, a user, when they make that request, they need to authenticate in some way. And you could make them send up their username and password every time, but that's not very secure. So what we'll do instead is we'll have them, authenticate one time. They'll send in a username and password to our backend service. We'll create a session token for them, store it in our database, and return that token to them, and they'll return it on every subsequent request. So if you look here, I have my user, I have my backend service. That first thing we're going to do there is on top, that user saying, hey, can I log in? My username is Alex Debris. My password is I love DynamoDB. Going to send that to the backend service. Backend service is going to check that username, check that password, make sure they match. And if they do, store that token and send it back and say, hey, next time you make a request, send this token up back with that request. Once we have that token, the user, wants to post some message and they say, hey, can I post this message? Here's my authorization token that you gave me already. Backend service is going to take that token, look in their session store, look it up, make sure it's who they claim it is, and then, enable them to post that message and respond back saying, hey, that was valid. You can post this message. It all worked. In addition to sort of this create and get session token workflows that we have, we also need to account for expiring or deleting these tokens. The first example we have there is we just want to expire these tokens occasionally, because the longer these tokens are out there, the riskier it is that someone nefarious will get them and use them for bad purposes. So we'll expire those tokens 1 week after they've been created. Additionally, we might want to let a user expire all the tokens that they have for themselves. So, they could have different tokens on different clients. So one is on their laptop, one is on their phone, and perhaps they're worried that their account got hacked for some reason. They could make a request to that backend saying, hey, I'm worried I was hacked. Can you just delete all my tokens, basically force re-authentication there? The backend service will say, sure thing, I can do that. We'll look up all the tokens for that user, delete those tokens, and then make the user re-authenticate on the next time. So let's wrap that up, make sure we understand our application. Again, we're just building a simple session store that's used for authentication in our app. In addition to, basic getting and setting of those tokens, we also need to have token expiry after a certain amount of time, as well as mass expiration if a user requests it. So now that we know that, let's go in and let's build our ERD, that entity relationship diagram. That ERD is pretty simple here. Basically, we have that username there on the left. There's a one-to-many relationship between users and sessions. The sessions are all on the right there. A session has, the session token, which identifies it, but also has these created at and expires at attributes on it. In this particular example, I'm including attributes on the entities themselves, but I usually don't. I just did because it looked pretty blank without them in this one, since it's pretty small. So we've got two entities in our application. We have users, and users have multiple sessions. So let's define and list out our access patterns. We just covered these, so this should be quick. So number one, we have that create session access pattern, which is going to be when a user sends up that username and password to get a new session. On subsequent requests, they'll include that session token. So we have that get session access pattern as well. Number three, occasionally we want to delete sessions, and this is a time-based access pattern. We want to delete it 1 week after it's been created. And then finally, we have the delete sessions for user. This is going to be a manual action by the user where they say, hey, delete all the sessions for me, make me re-authenticate. So let's get started with the fun part. Let's design our DynamoDB table, design our primary key and our indexes to handle the access patterns that we have. The first question you're always going to ask yourself as you're designing your table is, do I want to use a simple or a composite primary key? Now, in most cases, you're going to opt for that composite primary key. That enables those more complex access patterns, especially if you have any sort of fetch many access patterns. You're going to need to use that composite primary key with that query to handle those. It's actually more up in the air in this situation on whether we go with a simple composite primary key. So let's hold that right now. And let's think about the interesting requirements we have in our application. That's usually a good place to start. Number one, we have a uniqueness requirement on that token, because when we create a token, we want to make sure that there's no one else that has that token. Otherwise, you could have some mistaken identity issues, and that would be a pretty big problem here. So you really want to make sure that token is unique. Because of that, we need to make sure our session's primary key has only the session ID in it. It can't also have the username key, because otherwise that would only ensure that we're unique with that token across that username, but it's not going to give us that unique across the global namespace here. So we're actually going to go with a simple primary key in this situation. Another interesting requirement we have is that time-based deletion of sessions. We'll see how to handle that in a second. And then finally, that last interesting requirement we have is handling manual deletion of all sessions for a particular user. So now we've got sort of a fetch many access pattern, fetching all of them for a particular user, and we'll see how to handle that. So let's get started with our first two access patterns, just around create and get session. And this, once we design what that session item looks like, it's going to be easy to sort of get and create that session. Here's an example table we're going to have here, and we're just going to have that simple primary key where the partition key is called session token. So we're not even overloading our primary key names like we might do if we had multiple entity types in one table. Since we're just having sort of one entity type here, the session itself, we don't need to do that. We can actually give it a meaningful name of session token. So you can see we're using that session token as the primary key there. That's going to uniquely identify each session in our thing. That's also going to be what a client will pass up to us in that authorization header. They'll give us that session token. You can also see here, in addition to the username attributes, we also have created at and expires at, and that'll tell us when that token expires, when it's no longer usable, so that we can make sure that a user can't authenticate with that they need to get a new token. Let's pop over to the code and see what that'll look like. So this is our create session handler here. This is just some JSON schema we're defining to handle the input here. So we're making sure our request body has both a username and a password. Then we have this handler. We would have some authentication here just to make sure that the username and password match. I'm going to skip that because I don't want to really get into that here, but that's something you absolutely need to have in your application. But then we just have this create session function that is going to, we'll pass in that username that we get there, and it's going to return a session ID for us. If we go over and look at that create session here, it's got that username. It's going to create a UUID for that session ID. It's also going to set the expires at to, the created at time plus the expiration, which is just 7 days here. So that's the number of seconds in 7 days. And then we're just going to do a put item. We're going to enter that item into our table. It's got the session ID. It's got the username, created at, expires at, TTL, all that there. We're also including this condition expression to make sure that there's not another item with this same session ID, because that's not what we want there. If that goes in fine, then we're just going to return the session ID. If that throws an error, we'll check that error, and if it's a condition check failed exception, that means there already is a session with this token, which means we got a UUID collision, which would be pretty weird. So that's probably not likely the error we'll get there. We'll probably get some other sort of error like, maybe we had a throttling issue or something like that. And then we'll just say, we could not create a session token, have them retry in the event that happens. So let's try executing this code just to try that it works. I've already deployed this up to AWS Lambda and API Gateway. What I have, I've defined a base URL, which you'll get if you deploy this code, so you can see it there. This is going to make a post request to that /sessions endpoint. You can see my payload body here. I have a username, Alex Debris, and I have my password, I love DynamoDB. So let's see if that works. We'll send that up here. And it returned back successfully with this session ID. So now we've got this session ID. Let's copy that. And now we'll try our get session endpoint. The same thing we're going to do here. This is going to be get on that same endpoint. And what it's going to do is it's going to use the authorization header. And we're going to do a bearer token. And the value will just be bearer space and then that session ID. So let's send that up and see if it can find us. And see what it found there is that username Alex Debris. So even though I didn't include that in my request anywhere, what it did is it went and looked in DynamoDB, found that token, and got it. Just to finish that off, let's check out the code for that get session. So this is my get session. HTTP handler here. Again, I've got that JSON schema defining it. This time I want a header, and I want the authorization header specifically that we saw that I put up there in a bearer token. In my handler, then I'm just stripping out that session ID by replacing that bearer with empty. So I'm just stripping that bearer space off, and then I pass in that session ID to this get session function, and that's going to return a username for me, which I'll return there. If we hop over into our data layer, then we have this get session function. Takes that session ID. All it's going to do is run that get item request against DynamoDB using that session ID there. If it doesn't find an item back, then it's going to say, hey, session does not exist. Otherwise, it's going to return the username from this username attribute here. So that's how we handle our first two access patterns, the create session, the get session, both the main access patterns there. Let's move on to our next one, which is that time-based expiry, right? Where we want to occasionally expire these items after 1 week so that a user has to re-authenticate. And there are a couple different ways we could do this. Number one, we could keep track of a list of all these tokens and when they expire and expire them on a schedule. So maybe we write some sort of data structure that stores them in order of expiration. Occasionally we check that structure to see if any items need to be expired and go out and do that. I don't prefer to do that. It's a lot of manual work on our end to maintain that structure, to have this sort of cron job or some sort of scheduled job to scan that and then check for deletes. So I prefer not to do that if possible. The second thing we could do is a lazy delete. So whenever someone makes a request with a particular session token, we could look up that token and see if it has already expired. If it has, then we can delete that token from our database and also return to them, hey, session not found, you need to re-authenticate. That works. That's probably my second favorite approach. The big thing with this is now your table is going to have a lot of extra sessions in it, because you can imagine someone that logs in once on a particular device and never comes back. So then, maybe their token is expired, but they never send that token back. So then it never gets expired. It just hangs around in your table, sort of cluttering up that table. The last option, which is what we're going to go with, and this is my preferred option, is we're going to use DynamoDB time to live, the TTL, which is where you can set an attribute on your DynamoDB table and say, hey, this is going to be a number attribute. It's going to be an epoch timestamp. Whenever you have an item that the current time is greater than the attribute for that item, you just delete that record from the table. So going back to our table, we're going to add this additional attribute there on the right, outlined in red, that TTL attribute. It's going to be an epoch timestamp. You notice we still have the expires at ISO timestamp there, and I prefer to sort of have both of these, just because that expires at is more readable if you need to. It's human readable, whereas if you look at that TTL, it's a number, you can't figure that out, so you're gonna have to copy paste it into some epoch converter if you need to. So I prefer to have both of those in situations like this. Let's take a quick look on what it looks like to enable something like that. So here's some CloudFormation I have to provision my table. You can see this is my session store table, and it's got things like my attribute and my primary key defined. Additionally, at the bottom here, it has that time to live specification. So I was saying I want that enabled. The attribute name that they need to look at is called TTL, and DynamoDB is going to manage all that. All right, so that's how we handle that time-based expiry. We're going to use that TTL feature that DynamoDB provides for us to automatically expire those items. The last access pattern we have is manual deletion of all the tokens for a user. So if we go back to our table, what we're going to do here, when this user sends up this request, we need to find all the tokens for a user and delete those. And you'll see the username is on there, but it's an attribute. It's not in that primary key, so we can't search directly by that. What we're going to do instead is we're going to create a secondary index using that username that's going to allow us to query that, find all the sessions for a particular user, and then once we have those items, those sessions, we'll go back and delete each of those items. So it's going to be a two-step process. Here's what our secondary index will look like. You can see that all the tokens for Alex Debris have now been put into the same partition, so we can make that nice, efficient query. Let's take a look at that in our code. First of all, let's provision that secondary index. So we've defined this attribute in our attribute definitions, that username that's going to be used in our secondary index. And then we've added this global secondary indexes section right here. We're calling this the user index. The key schema has a username with which is of type hash, and we're just going to project the keys into that index. So let's take a look at our handler code here. This is going to be a two-step process, but the first thing we're going to do is check the authorization header that comes in and check that session to make sure that whoever is making the request, they're asking to delete the sessions for themselves, not for someone else. And if the username that we return from that get session does not match the username in that path, we're going to throw an error there and say that's an invalid request. The second thing we're going to do is then actually delete the sessions for that user. And let's take a look at the code for that. In that delete sessions for user code, we're doing two more things. First of all, we're going to do a query operation against that index. So here we're using that index name where we're finding all the tokens that exist for that user. So we have a key condition expression where we're passing that in for that username and getting that. If we get an error there, we might not be able to find the sessions. Then once we've done that, then we're going to queue up our deletes and do that. And for each one, we're going to make a delete request. And then we're just going to go and do DynamoDB batch write item and delete all those sessions for us. Wait for that to happen. If there's an error there, we're going to say, we could not delete, but otherwise it worked out to delete all those. Finally, let's just make sure that works with our request. So again, we have our get session here. We showed this earlier. Here's our token. I'm just going to make that request again just to make sure that it still works. So I send that up. I'm getting that Alex Debris token back. If we go over to our delete sessions for user thing, we have a path of sessions/Alex Debris, which is the username. We're making that delete request. Again, we're passing up that same authorization, that session token in that authorization header. Let's send that up. And you can see it was deleted for the username. If we go back to that get session now and we run that, we're still using our old token, which should have just been deleted. Let's try and send that up. And now it says session does not exist. So it's going to make me re-authenticate because all those tokens have been deleted for this user. All right, that's the end of this first data modeling example we have. Let's review what we did here. First of all, we're just using a simple primary key of session ID for our table. Since we're just storing that single entity type, we don't need to overload and use generic names like PK, SK. We can use that simple primary key, given an actual meaningful name like session ID. Second, we configured TTL using that TTL attribute. That's going to delete our sessions once they've expired. And then finally, we have a single secondary index that has a simple primary key of username. Now, I always recommend building an entity chart so you know what your entities look like in your table and what the patterns are for the keys. It's very simple and basic for this one. We only have one entity. It is that session, and the session ID value is going to be the session ID. So this entity chart looks kind of silly, but we'll see in subsequent chapters what that really looks like when you get more. Finally, I also recommend building out an access patterns chart and discuss how you'll handle those. So this is what I have here. You can see down the left, we have the different access patterns. And then we say, hey, what index or table we're using, what are the parameters and any notes you have. So across the top there, that create session, we're going to use that on the main table. The parameter you're going to have there is that session token. And a note that you want to use there is, add a condition expression to ensure there aren't any duplicates. You don't want to be giving out the same session to multiple people. Second access pattern we have here is that get session. Again, that's going to happen on that main index. You're going to have that session token parameter. And one thing you want to do there is add a filter expression on there to ensure the token is not expired, because the DynamoDB TTL, it's only going to give you, they say they generally delete within 48 hours. I usually see better than that, but just in case, you want to use that filter expression to filter out any tokens that should have expired but haven't been. That third access pattern we have is the delete session, the time-based one, where we want to delete them once that session has expired. There is no index or parameters here because, as it says in the notes on the right, the expiration is all handled by DynamoDB TTL. So that's a hands-off way for us to handle it. But we do have that other access pattern, that fourth one, that is delete sessions on a manual basis. And you can see there's actually a two-step process there. The first thing we're going to do is hit that user index with that username and find all the tokens for the user. Once we've done that, then we're going to go back to that main table. And for each token, we'll have that session token and delete each token returned from step one. That's the end of the first example. Very basic one, simple table, simple secondary index. The next one's going to get a little more complex. We're going to have relationships. We're going to have a lot more. So check that out. That is the e-commerce store example.